Thank you for joining us today. I'm Dave Cocking and I'm joined by DesignBuilder's Managing Director Andy Tindale. Over the next 40 minutes or so, I'll introduce you to the very latest developments in DesignBuilder. There will be time at the end to answer your questions. I'll first explain how we've improved the import process for GBXML models from BIM, then show you the new combined heat and moisture models and introduce some of our new HVAC developments, including VRF and various heat pump systems. Finally, I'll highlight new DesignBuilder tools to customize simulations using the Energy Plus EMS. For those of you not familiar with DesignBuilder, it's a graphical front end which enables you to access the power of industry-leading engines like Energy Plus and Radiance in a much simpler and more time-efficient way than modelling using the native tools for these engines. Our interface also enables you to use other simulation engines, for example, to run energy performance compliance calculations specific to different countries in Europe. This means that you can run different calculations using the same model simply by changing the analysis mode. DesignBuilder also has its own CFD engine, which is fully integrated with the modeler, again allowing you to use the same model geometry to run CFD simulations. You can link thermal simulation outputs to create boundary conditions for your internal CFD analyses. In addition to providing powerful geometric modelling tools, DesignBuilder's user-friendly interface and efficient data management system significantly reduces the amount of modelling time required. These qualities help to reduce the risk of modelling mistakes and make you more productive. Moving on to our latest developments, I'll start by explaining how our new Revit tools can provide a robust GBXML import from BIM tools such as Graphisoft, MicroStation and Revit itself. You can, of course, also import GBXML files exported from other simulation software. DesignBuilder's new GBXML import mechanism enables it to better handle instances where the GBXML file has errors such as missing surfaces, as well as providing automatic story space grouping for easy navigation and edits. DesignBuilder's new tools eliminate gaps between zones, repair non-enclosed spaces, and eliminate gaps in surfaces. I'll start the GBXML import process by opening the Import BIM Model dialog and selecting the file I want to import. Our tests prove that the new BIM import tools work well for large complex models, and the import process is now much faster. We'll use the Revit test model, which some of you may be familiar with. Here you can see a preview of the model. We can tailor the way the model is imported via the options here. I'll mention some of them to highlight new functionality. This new Create Story Block setting enables zones in the same story to be grouped into blocks. This makes navigation in the model much easier, as you'll see shortly. If this Import Thermal Properties option is selected, then DesignBuilder will load any materials, constructions and glazing system thermal properties present in the BIM model and assign them to surfaces and windows in DesignBuilder. This Allow Open Manifold Building Block setting is an important new feature that allows you to import spaces that have gaps in surfaces. I'd like to take this opportunity to stress that I'm using a version 4.5 beta today, and that these features will be available in a full release at the end of June. At that time, we're also intending to release an improved Revit plugin that we're currently working on. It's worth pointing out that if the surfaces in the BIM model entirely enclose the space, DesignBuilder will use those to create the zones where possible. Where surface data in the BIM model is not available, for example when a surface in a zone is incomplete, DesignBuilder can still import the space as defined in the BIM model. When the import finishes, you'll see this Import Messages screen. This screen highlights where construction or glazing data may be missing so that you can quickly address any issues. The list of unnamed zones may highlight that spaces such as vertical surface voids, ducts and pillars have been imported incorrectly as zones. You can easily remove these from the model. The list of blocks not fully enclosed indicates spaces that require checking and may need fixing or deleting. Zone 331 is one that requires investigation. I'll go to the unnamed zone in block 1. And you can see from the visual representation that this is likely to be a service void. I could simply delete the partition to merge the zone with the adjacent zone, having confirmed that it is not required. At building level, I'll look at zone 331. Where you can clearly see the holes in surfaces imported from the BIM model. These would not be a problem for Energy Plus simulations, but this block would require repair for daylighting and CFD calculations. Orbiting the building, you can see the geometry for all surfaces with no gaps. In the Navigator panel, you can see how the zones have been automatically grouped into their respective blocks, with block 1 containing all the ground floor zones, for example. This makes it really easy to navigate to a zone on a particular level. Our tests have shown that the new BIM import tools work reliably over a wide range of different models. The information I've just provided is all available from DesignBuilder's fully integrated searchable help file, which you can see here. Searching using the term GBXML, I can access the general information on GBXML imports and our link here at the bottom to the DesignBuilder Revit GBXML tutorial. I'll now delete the Revit model, which isn't ideal for webinar purposes, and I'll create a relatively simple small model using our geometry creation and editing tools. For those not familiar with DesignBuilder, I'll briefly explain some important concepts as I go. I'll start with a simple rectangular block 20 by 10 meters, which auto extrudes to the block height set here in the drawing options panel. Now I'll manipulate the existing geometry using the Add Surface tool to extend the block by 10 meters to create an L shape of equal proportions. I'll now add a monopitch upper story by creating a vertical surface. And then extending that surface the full length of the block below. Snaps are used to quickly and accurately create geometry in DesignBuilder, and also to ensure that there are no gaps between adjacent blocks. I'll now add a small reception zone on the ground floor using the partition tool. And I'll change the zone name to reception. Notice that here in the Activity tab, there are extensive pre-populated libraries for typical activities, including those required by LEED. I'll change the activity type to reception. DesignBuilder's unique data management system reduces data input, so saves time and reduces the risk of input errors. The most common data, such as the activity data here, is loaded at the building level, and that data is inherited by all the blocks and zones in the building. This means that you only need to change the data in blocks or zones which are different. So if this was a 100-zone office model, I might only need to change the activity setting in 10 or 20 of the zones which are not offices. The same principle is true for constructions, lighting, HVAC data, etc., with the most common data being loaded at building level. The next new feature I'd like to highlight is the integration of the Energy Plus moisture models into DesignBuilder. The two models are the simplified Effective Moisture Penetration Depth, or EMPD model, and the more detailed Heat and Moisture Transfer, or HAMT, Finite Difference model. Energy modelers and designers generally recognise the importance of moisture when considering internal conditions for spaces such as museums, requiring close humidity control. Moisture can also have a significant effect on internal comfort conditions and the performance of air conditioning systems. To accurately assess cooling system performance during periods when cooling is needed, you may need to know the moisture conditions of the building. Using the more advanced moisture models can be one way of closing the gap between predicted and actual cooling energy consumption. The EMP model is a simplified approach to simulate surface moisture exchange with zone air. The data and settings are accessed in the DesignBuilder at the materials level for the building fabric, here in the Constructions tab. Whilst editing the construction, I'll just point out the Condensation Analysis tab, which some of you may not be familiar with, but is relevant to our discussion on moisture. Here you can see interstitial and surface condensation results on a glazer diagram, with results assessed according to the ISO 13788 standard. Here in the Material Edit dialog, you can also create your own phase change materials if you wish to supplement the existing DesignBuilder phase change material library. I'll take a look at the EMPD data first. The moisture transfer settings are found here at the bottom of the General tab, and we can edit the properties or create and use our own. The data here is populated for this particular gypsum material and is included for many of the DesignBuilder library materials, but you can of course define your own properties if required. We can select which data we wish to see using this drop-down menu. The data required to use the simpler EMPD model is contained on this one EMPD tab. The heat and moisture transfer tabs contain the various curves required for the more detailed HAMT model. The HAMT algorithm is a fully coupled, one-dimensional, finite element heat and moisture transfer model. As well as simulating the effects of moisture buffering, HAMT can also provide temperature and moisture profiles through composite building elements and help to identify surfaces with high humidity. You can choose which simulation algorithm you wish to use in the Model Options Simulation tab. I'll now show a couple of slides which indicate the kind of data that can be generated when using the HAMT combined heat and moisture transfer method. This first slide shows the dynamically varying temperature profile through an external wall. The second slide shows the relative humidity for the same wall construction over the whole year. Before discussing detail HVAC, I'll briefly explain simple HVAC. The simple HVAC method is very easy to define and quick to simulate, and is ideal for early stage analysis to gain a sense of the energy flows associated with HVAC systems without having to model them in detail. The Simple HVAC tab allows you to quickly define typical systems by selecting them from a predefined list, which you can see here. For this fan core unit, for example, we can define the key system characteristics, including mechanical ventilation, heating and cooling, and natural ventilation. I'll now move on to show you some of the key features of our new detailed HVAC systems. While Simple HVAC is perfect for quick testing or early stage analysis, there will clearly be many occasions when it's not sufficient. In that case, we select the more detailed HVAC analysis mode. Here's the growing library of pre-configured templates, enabling you to quickly load typical HVAC systems to your model. You can also create your own templates and add them to the library should you want to. At the top, you'll find the 10 pre-configured ASHRAE 90.1 baseline systems and a couple of domestic hot water systems, including a solar thermal variation. Our range of pre-configured HVAC templates covers the most typical systems, including a variety of air and ground source heat pumps, chilled ceilings and beams and heated floor, and constant volume, DOAS, fan core unit, and variable air volume systems. Although templates are typically the easiest and quickest HVAC definition method, you can also create your system by building it from individual components, or load a template as a starting point and configure it to meet your needs. The focus of today will be on the new functionality. In the interest of time, I'll quickly review some of the new systems before looking at others in more detail. I'll load the VAV reheat system, incorporating one of our new features, a fluid cooler, sometimes called a dry cooler, which enables you to model a remote air-cooled chiller condenser. The next system I'd like to show you is the air-to-water heat pump, sometimes called the air source heat pump, with series boiler, from our new list of heat pump systems. The heat pump supplies hot refrigerant to the heat exchanger in the Energy Plus water heater tank component. This is a typical configuration to prevent cycling of the heat pump and to improve efficiency. You'll see from the schematic that this system also uses the Energy Plus fluid-to-fluid heat exchanger component, which provides a very flexible way of connecting and exchanging energy between plant loops for different applications. In this case, the heat exchanger enables the hot water from the water heater to be further heated by the boiler if the heat pump can't cope at peak load conditions. This same heat exchanger component can be used for other applications, such as this waterside economizer, to allow free cooling using a cooling tower when the load on the water-cooled chiller is low. The various heat exchanger types provided by Energy Plus, such as parallel flow, counterflow and crossflow, can be selected as required. This heat exchanger component adds a huge amount of extra flexibility in the ways that heat can be exchanged between systems. I'll now show how easy it is to modify a default system loaded from template by adding and connecting a district heating system. District heating and cooling is a very simple system requiring minimum data input, and in this case could be configured as the lead heat source. Another new system type is the water-to-air heat pump, and we currently have two pre-configured templates, as you can see here. The final new HVAC system I want to show you is variable refrigerant flow, or VRF, which is becoming increasingly common in many countries due to its high efficiency and cost effectiveness. The VRF is a relatively simple system used to satisfy the zone sensible loads, so is typically used in conjunction with a dedicated outdoor air system, or DOAS, to provide the required ventilation air. The DOAS system would normally have heat recovery and some form of demand-based control, as used in this template. However, this can easily be switched off if required. The schematic of the VRF system shows it simply as the outdoor unit connected via refrigerant pipework to the indoor unit. This can be used to model a standard 2-pipe system or a 3-pipe heat recovery system. The zone terminal unit comprises of a fan and 2 coils, and as with all HVAC systems, you can navigate to and edit all components. Here you can see the various options available for the whole terminal unit. And here you can see the options available at coil level. We'll now take a look at the VRF outdoor unit edit options. The whole VRF system is auto-sizable in the event that you don't have sufficient data. You can load one of the existing library templates, which includes the generic Energy Plus example VRF template. You may wish to use that if you have no system data. We also provide manufacturer's system templates, but for detailed VRF modelling, you'll generally need to create your own system based on current manufacturer's data. I'll load this generic Energy Plus VRF example template to enable me to compare the results with the LG template a little later. Loading the template is a very quick way of loading all the data for a particular system. At the outdoor unit level, we can define parameters common to both heating and cooling, such as the condenser type, which can be air, water, or evaporatively cooled. Going to the Cooling tab, I can access the cooling specific data, such as the rated capacity and the COP. You'll no doubt by now have noticed the number of curves. To model a VRF system accurately requires the use of a number of curves to determine performance at each time step. And these differ for heating, cooling, and heat recovery. Hence the need for separate tabs to input that data. It is possible to simplify VRF modelling where appropriate by selecting the single curve options. And I'll press OK to select the changes that I've made. As the curves are essential to model VRF systems accurately, we've provided spreadsheets to help you create the curve coefficients. The spreadsheets take you through the process step by step with instructions and will soon be available free with other useful VRF resources from our website downloads page. I'll now run a simulation to compare the performance of two different VRF systems to highlight new features in our Simulation Manager and Results Viewer tool. We already have a results set prepared for the LG VRF system, so I'll run a new simulation using the generic Energy Plus VRF system to enable direct comparison. Going to the simulation calculation options here, I'll give the calculation a meaningful name and run a quick Summer Design Week simulation generating hourly results. The Simulation Manager allows you to queue and run multiple simulations in parallel on your local machine, on a network server, or on the cloud. This has many benefits, including freeing up the local machine to enable you to continue working on the model during simulations and store and list result sets. Our testing has shown that Energy Plus version 8.3 is up to 3.5 times faster than version 8.1, with the greatest benefits for large, complex models. One of the improvements in version 4.5 is the ability to load multiple result sets directly from the Simulation Manager to the Results Viewer. Another new improvement is the ability to load data for all result sets in one click. For example, here I've loaded the total electricity consumption for the whole building, where the only difference in this case is the VRF system simulated. This shows that the default LG system is generally beneficial during the Summer Design Week. Clearly, this could be for a variety of reasons. The most important point being to show you how to directly compare system results in the Results Viewer. This latest version of DesignBuilder sees the addition of the Energy Plus Energy Management System, or EMS, and Functional Mockup Unit, or FMU, to DesignBuilder. These will be available as beta features in the version 4.5 release. The FMU enables you to link Energy Plus to other simulation programs such as MATLAB, or to write your own code to enable functionality beyond that provided by Energy Plus. The EMS, on the other hand, provides an easier way to write relatively simple code to customize the simulation. The EMS can access sensor output data and use this to control pumps, fans, HVAC equipment and set points, lighting, on-site electricity generation equipment, etc. The entire EMS program is contained within the IDF file generated by DesignBuilder, enabling you to run your simulations locally or on remote servers. Energy Plus provides an inbuilt language called ERL, and DesignBuilder provides some significant extensions. These allow a single piece of EMS code to be used by every zone, which makes it portable between models and significantly reduces the time and effort to use the EMS. Some example EMS applications are customizing the HVAC sizing calculations, supplying an air system via an earth loop, controlling natural ventilation systems on parameters such as CO2 or humidity, and modeling special glazing systems such as thermochromic. There are many uses for the EMS, and our program help contains much more detail. We'll now take a quick look at the EMS interface. and highlight some key features. A simple EMS program might sense a parameter such as zone air temperature using a sensor, and then control other equipment such as your HVAC heating system using an actuator, the two being linked through simple EMS code. I'll now open an existing EMS program so I can highlight some of the additional usability features provided by DesignBuilder EMS. Much of the code you might need can be added from utility dialogues accessed from the links shown here. There's a short delay here while DesignBuilder accesses the sensor list from Energy Plus. The Add Sensor dialog includes a full list of all available sensors based on your specific model. From the sensor list, I can select the Zone Air CO2 concentration sensor, which automatically loads the relevant code. I'll now add an actuator, which is the way the EMS changes the behaviour of the simulation. The actuator list, again, is automatically based on the currently loaded model. And here I'll select the Block 1 reception heating set point schedule. Code can then easily be written to modify the value of this schedule at each time step during the simulation. This could be used, for example, to model a bespoke occupancy control mechanism. This is only a basic illustration of the EMS features provided in DesignBuilder, with many more utilities available to you. EMS is incredibly powerful and provides an almost infinite range of possibilities for customizing the simulation. So that's all the material that we plan to cover today. But if you'd like to submit text questions, we'll do our best to answer as many of them as we can in the next half an hour or so. This webinar was recorded and you'll receive an email with the relevant details should you wish to review it. There are lots of other free resources available on our website or on YouTube, including past webinars and more detailed video tutorials. I'll now hand over to Andy to review and answer your questions.
Thank you, Dave. I'm just going to look through the questions and pick some out. There's a question here asking about what happens to the interior wall volume, 10-20 centimeters thickness of wall, when we import the Revit model to DesignBuilder. So with the latest version of DesignBuilder, we use the surface mechanism within Revit, which means that we import the external surface dimensions. And because that maps very nicely to the DesignBuilder block concept, and also because we can import the thickness of those constructions, what you should find is that provided the model is set up correctly in Revit, you will get an identical representation within DesignBuilder, because DesignBuilder can identify the thickness of each surface from Revit through the construction. There's a question asking whether the moisture transfer algorithm significantly increases processing time. I haven't done any tests on this, but because it uses a finite difference approach to the calculations, it's almost certain to increase the simulation time, and the time that it takes will depend on the time step. So if you use very short time steps, very short time steps, then of course the simulation time will be a lot longer. So yes, it will significantly increase processing time. There's a question asking about providing more information about the FMU export. To be honest, I'm not really in a very good position to give you that information. What I can say about it is that we have actually implemented a test FMU application within DesignBuilder, and that's to implement the Nottingham University occupant behaviour model. So what we've got is the occupant behaviour model written in C++, and that's linked to DesignBuilder. And at the moment we're writing some user interface to make that work. But I can't give you any more details than that, other than to say that DesignBuilder will fully handle the generation of the .fmu file, which is provided to Energy Plus, and that it should all work behind the scenes, including simulation on remote servers and also on your local machine. There's a question about whether there's a tutorial available on how to generate and export the BIM model correctly as an XML file to be able to import it into DesignBuilder. Yes, there is indeed, but it is specifically tailored to Revit, the tutorial that we have at the moment. And I did flash up earlier a link at the bottom of the GBXML import web page in our help. If you click on the link right at the very bottom, I'll just click on that quickly, and we'll just have a very quick look at the tutorial that we can provide you with. And basically, it just gives you an indication of the important steps, how to define the rooms within Revit in this case, how to set up the room boundaries, the upper and lower bounding surfaces, offsets, and what have you. And also information about the plugin that is provided for DesignBuilder within Revit. So if I scroll through here, this is the dialog which is used within Revit. This is the Revit native dialog. Although we haven't done this yet, I understand there are alternative ways provided within latest versions of Revit, certainly in version 2016. Which provide even better than the current versions GBXML, and we plan to implement that quite soon. However, if I continue to scroll down, we'll see the current Revit plugin, which we're in the process of improving. So when you click on the export button within Revit, that brings up the dialog, and then you can generate a DesignBuilder file from there. There's a question here about whether the new DesignBuilder Energy Plus combination will produce different results to the current version. So generally speaking, from our tests, certainly Energy Plus version 8.3 doesn't produce different results to versions 8.1 and 8.2. There may be small differences in results. So although it's been fully translated from Fortran into C++, the results from our tests seem to be pretty much identical, although the simulation speeds are a lot better, especially for very large models. On the DesignBuilder side, the IDF that DesignBuilder generates should be pretty much the same. I couldn't guarantee, though, that the results will be identical. The only way to be sure would be to run a test simulation and get a sense from that. There's a question here about ground modelling. I'm not sure that we mentioned this in our webinar, but we have implemented a mechanism for accessing the ground domain mechanism within Energy Plus, and we're writing the help for that at the moment. So that will be made available in hopefully by next week. We're halfway through that process. There's a question about 2D and 3D thermal bridging effects. So, I mean, I think part of the Energy Plus ground model introduces a 3D ground conduction mechanism. I don't think that Energy Plus per se has a 3D thermal bridging effect, but DesignBuilder certainly has linear thermal bridging in place in version 4, and but no 3D bridging. Can we draw curved buildings? You can certainly draw curves in DesignBuilder. Those curves will be represented as segments for the purposes of simulation though. So within DesignBuilder you can draw arcs. You can stretch those out into curves of general sorts. But Energy Plus doesn't understand curves, it only understands flat surfaces. So we convert those in DesignBuilder into segments. There's a question about importing Energy Plus files, IDF files into DesignBuilder. We're asked this question fairly often, and we are going to implement that fairly soon. An important part of our recent work on BIM import has led to a very flexible mechanism which we're about to extend to allow IDF files to be imported and also IFC files. So that's just around the corner and should be ready for version 5. And certainly by the end of the year. Question about 4.5 release dates. We will be releasing new betas next week for 4.5, and we expect to release the final version by the end of June. Question about more information on the EMS interface. It's funny you should mention it because we were just discussing this before the webinar. I would very much like to provide a webinar purely on EMS because I think it's a very powerful mechanism, and it's certainly on our list of future webinars. I can't give you a date at this stage, but I think it's pretty much certain that we will provide a webinar on EMS at some point in the not too distant future. Question about modelling radiant heating and cooling in the new version. As I'm sure you're aware, the person who asked the question, that there is also already radiant heating floors and radiant cooling ceilings. I expect that the question is referring to a combined heating and cooling radiant system. That's on our list, and it's the next HVAC system that we plan to implement. So I would expect to see that in place certainly before the end of the year, over the next few months. Can we import a shading component from a BIM model? Yes, absolutely. I don't think we drew attention to that within the webinar demonstration, but DesignBuilder by default imports all shading surfaces into the BIM model. There's a question about what's new in version 4. Overall, I think the reference is about DesignBuilder version 4 entirely. There is a web page on our website which summarises all of the version 4 features, including the 4.0, 4.2, etc. So we find that, I think it's on, what's new in v4. So here you'll see the v4 features. And version 4 has been by far our biggest release since version 1, with a vast number of new features. So the full list is here. The ones in brackets here are the ones that are going to be released with 4.5. I'll leave you to review this in your yourself rather than going through it here in the webinar. Can building and component blocks be differentiated in the GBXML import? Yes, well, they'll be differentiated in the Revit or whichever BIM program that you're using. And yes, they'll come into DesignBuilder differentiated. So spaces, surfaces, etc. will define a building block, and shading surfaces will define component blocks. There's a question here about EMS asking, after adding sensors and actuators, how do you program their relation? We would like to have spent a bit more time detailing that. I can show you very quickly an example program. I'm not going to have time to show you exactly how it works. But if I just, this is an example program to generate TM52 reports. I realise it's not the exact question you're asking, but it illustrates the mechanism where you have a program. So this is the main program that DesignBuilder calls, or rather Energy Plus calls during the simulation. And I don't know if you can see within the code here very clearly, but DesignBuilder or Energy Plus sets various variables during the simulation, and those variables are used to generate new reports. Perhaps this isn't the greatest example to answer your particular question, but essentially the general answer is that the relationship is done through script that you write in a program. And in the case of the schedule being changed based on a reference to a sensor, essentially what you do is you set the new value. You override the value for the actuator. So we've got an actuator in this. Now again, this is a read-only script. I haven't got a very good example to show you here, but yeah, essentially you write code which overrides the current value of the schedule based on the sensor value and various other code that you could write. There's a question here about licensing. Can we upgrade the current version 4 to 4.5 for free, or what's the fee? There's no extra cost. So if you've got a version 4 license, you can upgrade at no extra charge to 4.5. And equally, if you've got an annual license, you can upgrade that. Again, that gives you whatever's the latest and greatest an annual license does. There's a question here about drawing curved walls in DesignBuilder. There's a tutorial that explains how to do that on our web page. I can show you quickly how to get there. But essentially, you use the curve type. I need to log in to get there. So under Training, Online Learning, Tutorials, and it's one of these. One of these tutorials will explain how to do it. But it's essentially when you're drawing a block, you can choose the radius type. Oh, here we are, drawing arcs, circular shapes, and domes. So just to make the point that the DesignBuilder tutorials are available free of charge, and actually the most convenient way of accessing them is probably from the YouTube site. So we've got a YouTube channel where you can access all of these tutorials. It's a very good way to get to know DesignBuilder, especially if you're not able to access any of the classroom training. There's a question here about setting and seeing the relative humidity of the ground, such as it can be done in temperature. As I showed you earlier in the webinar, if you use the HAMT, the combined heat and transfer method, you can certainly view the relative humidity at various nodes within a surface, but I don't think there's any way of setting the relative humidity. There's a question here about what are DesignBuilder's advantages over well-known BIM software using Energy Plus as well. I'm not familiar enough with the other systems to be able to answer that in any great detail, but what I can say is that relative to perhaps some of the systems that simply take a GBXML file or an IFC file and directly generate an IDF file, the one big advantage of using DesignBuilder within that process is that you get to see the data within DesignBuilder, and you can make any sort of edits that might be required to adjust the geometry as defined within the Revit model. What data was used to generate the LG train and VRF curves? That was tabular data accessed from LG train websites. So the process that Dave mentioned within the spreadsheets, there are mechanisms that we provide to allow you to paste the tabular data into a spreadsheet in a particular format, and then you can copy that over into this spreadsheet, which actually generates the coefficients. So it's a fairly clear process. I couldn't, with my hand on my heart, say it's a very easy, quick and easy process as we have it now, although we are planning to simplify and improve it. But it's basically based on tabular manufacturer's data. Question here about Autodesk claims that they've renewed Energy Plus engine and it's 20 times faster than the conventional Energy Plus. Is this for real? And if yes, how? It is true. In fact, 20 times is, you can see faster than that even in some cases, depending on what you compare it against. So what Autodesk have done is to, they've translated the Fortran version of Energy Plus, that was Energy Plus 8.1, they've translated that into C++, and that's involved, or that's provided some great speed improvements, not in all cases. In fact, in some cases you do see even a small reduction in speed, but that's only in certain unusual situations. As far as we've seen, generally speaking, even for small models, you'll see around a 15% increase in speed. With large models, on fast machines, we've been testing an 800 zone hospital model, for example, on a very fast Xeon processor, and we're seeing 3.5 times speed increases for the standard version of Energy Plus. Now, those 20 times speed improvements that you refer to, that's for a special compiled version that Autodesk have, and also they're not the only ones. There's also an option from JES, the JE Plus approach, and also Apidea. So there's three different cloud options for simulating fast versions of Energy Plus. I can't say anything about how the Autodesk mechanism actually works, but certainly the Apidea and the JES implementations work by splitting the simulation into 12 monthly simulations. So instead of running one simulation over the whole year. They run 12 simulations in parallel, and that gives you roughly about a 10 times speed increase. The 20 times that you referred to, and maybe 30 times for certain cases, that's all about a combination of the split simulation combined with the faster C++ implementation for big models. So yes, it is for real, and we're rather excited about these big speed improvements. We're testing, at the moment, we're testing some of these mechanisms internally, and it's looking really good. We'll have more news on that in the fairly near future. Is there a way to import a model from SketchUp? There is. If you've got a plugin that generates GBXML, and I know there's a plugin called GModeler, you can use that to generate GBXML data, and then DesignBuilder can read that GBXML in. You didn't talk about CFD in the webinar. Are there any changes compared to previous DesignBuilder versions? Will you be introducing the option to generate non-Cartesian grid to better deal with curved blocks? Yes, we're working on some significant improvements to our CFD software at the moment. I can't give you any details at this stage, but it will certainly deal with non-Cartesian grids, body-fitted coordinates, various new turbulence models, and different ways of outputting data, including streams of airflow, etc. We're expecting to release that in version 5 next year, although I can't say that it will be available in 5.0. It's more likely, I suspect, to be available perhaps this time next year. There's a question about whether we can view results for only specific types of zones, for example, offices or classrooms in a mixed-use building. You'd have to use the results viewer to do that, and I guess it's possible, but there's no mechanism within DesignBuilder to easily do it. We've got some fairly major plans for improving the results viewer in future, so I'm pretty sure that will be included in future versions. The only other way of doing that would be to exclude. I mean, if you only wanted to run a simulation of just the classrooms or just the offices, that's fairly easy to do by using the exclude option. Will the new release affect any SBEM features of the current software? So this is a question specifically related to the UK SBEM mechanism. Version 4.5 that we're talking about here, I don't know if we're going to get that approved for the UK. We'll have to see a bit later in the year. I know there's a new version required for Scotland, so we may have to get it approved for that. So really, you're still with version 4.2 at the moment. Yeah, so that's just about a limitation on the number of times that we can gain approval for our software. There's only a fixed number of ways, or times rather, per year that we can get approval. So we're, in a sense, our hands are tied on that one. We'd like to approve every new version, but it's not really possible at the moment. Question: what is the difference between DesignBuilder EMS and Energy Plus EMS? Well, it's the same thing, except that DesignBuilder provides an extra layer of code, or rather an extra layer of language capability. So DesignBuilder allows you to set up loops, for example, within the EMS to allow you to write code that's portable between different models. So in the case of a particular set of code I showed you earlier, I'm not sure if it's on the screen at the moment. Yeah, here we go. So if I show you this SIBSI TM52 output, this is an example of some EMS code that we use in DesignBuilder behind the scenes for generating some specific outputs. If I scroll down towards the actual program part, you can see some loop commands here. This for all occupied non-cooled zones statement, that's not Energy Plus, that's DesignBuilder language. And then within a loop, you can pick up the loop zone variable name. So DesignBuilder will replace the name, the current zone within the loop with the zone name. So it's a really nice way of writing code once and being able to reuse that multiple times in other models. There are other differences in the DesignBuilder versus the Energy Plus EMS, but it's essentially the same thing. DesignBuilder is accessing the Energy Plus EMS, and DesignBuilder writes pure EMS to Energy Plus. It's just that it pre-processes the script that you write and generates some specific EMS code for Energy Plus to simulate. Another example here is, you can see this is a DesignBuilder language feature here. If the building attribute time step output equals 1, then we'll have an extra output variable. So that's another sort of language construct to allow us to access data within the DesignBuilder model and influence the way that the EMS script is written out to Energy Plus. Are you going to have storage DHW systems? Yep, that's been in there since version 3 as far as I know. If I'm understanding the question correctly, you can certainly set up a DHW system. Oops. Well, I won't go into it and show you right now, but it's a fairly standard DesignBuilder DHW system. And you can feed that DHW with a boiler. You can use a boiler to heat it. You can use an air source heat pump to heat it. And of course, you can store the water in a tank. And of course, you can also provide heat from a solar hot water system. You'll need to use the detailed HVAC mechanism to access these domestic hot water systems with storage. There's a question here about licensing again. The question asks, what do you mean by new, more flexible licensing system allowing software to be used offline? That's referring to, well, in version 3, if you kept the software offline for more than about a week, I think it was, maybe even less than that, maybe it was 3 days, I can't remember. DesignBuilder said, I need to talk to the server more often than this, and it closed. It didn't allow you to continue. But with version 4, you license once, and that downloads the license to your local machine, and then you can run offline without having internet access. IFC import, I think I may have mentioned already that that's on our list, and we plan to work on that very soon. Does the BIM import take zone names? Yes, it does. So the zone names that you define in your BIM software come through into DesignBuilder. There's a question about spreadsheets, and we mentioned the spreadsheets for generating VRF data, VRF curve coefficients, but the question is, what about other system types such as water source heat pumps? DesignBuilder haven't implemented any spreadsheets for water source heat pumps or any other system types. However, Energy Plus, I believe, have. And so if you need a more generic spreadsheet for generating curve coefficients, you can, if you download Energy Plus, they do provide some spreadsheets that allow you to do a lot of other different system types. I can't say any more detail on that because I've not used those spreadsheets myself, but I know they do exist. Question, will you add another VRF manufacturer's data to DB? I must admit, when we first started out on VRF modelling, we did plan to provide a full set of VRF data sets for all manufacturers. However, having seen the vast numbers of different system types available for all the different manufacturers and the rate that new systems are coming out, for the time being, we're not planning to do a full implementation of all the different VRF manufacturers' data. Unless someone offers to do it for us, it's unlikely we'll do that in the near term. So instead, we've provided this spreadsheet to allow you to do it yourself. If that turns out to be a problem, I think I'm right in saying, Dave, that we're providing a consultancy service to do that sort of thing.
We will, yes.
Yeah. Okay. Will external CFD be isothermal in the new version? So in other words, will there be a thermal element to the external simulations? I'm not sure about the first release. I suspect the first release of our new CFD may be isothermal, but we certainly plan to make it deal with heat in soon after that. So I can't answer that question for sure, but in the medium term, certainly it will deal with heat transfer for external CFD. There's a question here also about climate-based daylight modelling and whether we can provide the results that are required for version 4. We've been working on this recently, actually, and version 4.5 beta does include the spatial daylight autonomy outputs. And so we've got that already working. And we're currently working now on providing the annual sunlight exposure outputs, which we expect to make available later this year. So by the time version 5 is released next year, we'll have that all working and tested nicely. Right, there's a question about renewable energy systems and can DesignBuilder model renewable systems. So yes, DesignBuilder can model all of the main renewable systems, including photovoltaics, wind systems, solar thermal, and ground source heat pumps, etc., as you've seen before, as well as free cooling on the water and air side. We're also testing at the moment a new building integrated photovoltaic system, which we'll be making available very soon. We're running out of time now. I may to see if I can find any more questions. I'm afraid I'm not going to be able to answer all of your questions. I'm really sorry to those of you whose answers I've not been able to answer. Yeah, just one final answer. Will this webinar be available online later? Yes, it will. We'll be sending out a link to you all, to those that have attended this webinar and to those that may have missed it, and so you'll be able to watch a recording of this a little bit later. So I'm afraid we have to wrap up there. Thank you very much for listening today. We hope that you found the webinar interesting and informative, and I think we'll stop there. So thank you again, and goodbye.